y equals 36. So that dy over dx equals 2y minus 2x over 3y minus 2x.
So they gave us a problem, and that is our final goal, meaning they're grading in between work, okay? So just for teaching purpose, I'm going to rewrite this guy over here. Negative 4x times 1y. Okay, let's start deriving with respect to x. So I'm going to derive this guy with respect to x. So we know 2x squared is going to give us how many? 4. 4x. And 3y squared is going to give me 6y. And then what do I add? dy over dx. And our next one, we have our product rule. So we derive the first one, which is minus 4. I keep my second one. And then plus, I keep my first one. And you could just put one negative sign if you want. And when I derive the y piece, it's going to give me 1. And what do I need after that? dy over dx is equal to my constant has derivative of what? 0. And I'm going to do the same thing like last time. I'm going to do one go. I know I have to factor this out. I also know I have to subtract this guy and add this guy. Are we good with that? And then the remaining factor is what we're going to divide it by. So my one go is going to be dy over dx is equal to minus 4x, that's applying algebra 1, plus 4y. And then my factors that become inside the parentheses, which also means we're dividing on both sides. So we have 6y minus 4x. Now we're almost there. They're wanting us to further simplify. They can all be divided by what number? 2. So I get negative 2x plus 2y all over 3y minus 2x. But then, is it identical? It looks like they wanted the y's together and x's together. Let's go ahead and do that. We have 2y minus 2x all over 3y minus 2x. And the way they're going to grade is the following. Knowing how to derive the whole thing is 1 point. We should all get 1 point at least, okay? And then applying algebra 1 to move the things around, this piece right here is going to give you 1 point. The place you're not going to get a point is rewriting the original that I wanted. That's not going to give you any credit because all you did was copy. Are we okay with that? Okay? So you should at least get 2 points. How many points do you think is good out of 9 on each FRQ to be considered good? 7? I say 4 to 5. If you get 4, that's okay. Okay? If you get 5, even better. 7, even better, right? I said the wrong grammar. Oh well. All right. Kendall, go ahead and read part B.
Find the slope of the line tangent to the curve at each point in the curve where x equals 6.
Okay, so we're going to go ahead and plug in x equals 6. So we're looking for the tangent, find the slope of the tangent line, all right? So if my x is 6, I need to figure out what the y is from the original. So on my original equation, we have, let's write out 2 times 6 squared, and I have plus 3y squared minus 4 times 6y is equal to 36. Do we all see where the numbers are coming from? I'm simply plugging the 6 into the y. Now at some point, since I have a y squared and a y, we're going to factor. Again, that's algebra 1 topic. So let's see. If I compute this guy over here, are y'all okay if I just write 72? Then I have plus 3y squared. And the next one, I'm going to write minus 24. Y is equal to 36. So let's kind of recall factoring back in algebra 1. In algebra 1, we had something squared, some variable, and a constant is equal to 0. Y'all remember that? Okay, let's make it in that form. We have something squared, so it's 3y squared minus 24y. And I need to move this guy over. When I do, I get 72 minus 36 is another 36. And it's going to be a positive, right? All right, what is my GCF between 3, 24, and 36 that I could take out? 3. So that gives me y squared minus 8y plus what? 12. Now let's factor. What two numbers are going to satisfy the product of 12 and sum of negative 8?
6 and 2.
6 and 2? What kind of 6?
Negative 6.
So I'm going to say y minus 6 and y minus 2. And what that basically means, I have two values. The first y value is at 6. Second y value is at 2. Are we okay with that? So my points are, they gave us my x is 6, no matter what. And the two y values I found were 6 and 2. All right. So let's see what we're looking at for the slope of the line tangent 2. Because we're looking for slope of the line tangent 2, wasn't this the slope equation right here, dy over dx? We're simply plugging it in, the x's and the y's, but 2 times. So we have dy over dx. My first one says 2y minus 2x, meaning 2 times 6 minus 2 times 6, over 3y minus 2x will be 3 times 6 minus 2 times 6. Here's something kind of cool about this problem. Do y'all see the top is going to be 0 no matter what? 0. And the bottom is not going to be a 0, but some number. So if I have 0 divided by some other number than 0, what is that going to give us? 0. So what they want you to do is write this in a sentence. The slope of the line tangent to the curve at 6, 6 is 0. That's the first part. So finding that, was that a problem? No. So if you kind of think about it, part A and part B were not related. Okay? So just because you're stuck on part A does not mean you can't get part B. Sometimes it could be. All right? The next one, the same idea. We're plugging in 6 and 2. Let's do that. So dy over dx is equal to 2 times 2 minus 2 times 6 all over 3 times 2 minus 2 times 6. Now for this one, it's going to give us some value. So let's kind of do this mentally. The top one is going to give me 4 minus 12. How many is 4 minus 12? What kind of 8? Negative 8. The bottom one is going to give me 6 minus 12. How many is 6 minus 12? Negative 6. And that's going to simplify to what? 4 over 3. So we're going to write the same phrasing. The slope of the line tangent to the curve at, and be specific as to what point you use. 6, 2 is 4/3. So for this one, it's a lot of writing, but it's kind of nice though, because then your AP grader can be like, where can I give them credit? Knowing the slope is 0 at that specific point, you'll get 1 point. And my second one is another point. But you won't get there unless you find these two, right?
Couldn't you put m equals instead of slope equals?
Yeah, you could say m is equal to, for sure.
Oh, okay.